Okay, this is section 5.9, the integration by substitution. A lot of people are struggling with this type of problems. The thing is, with this type of problem, the more you do it, the better you will get. There's no other way around it. So the attempt here for this video, I'm going to go through a few problems in integration by substitution. These problems are in the problem set 5.9 part 2. You can find that on Blackboard. So when doing integration by substitution, there are something that you need to keep in mind. There are 5 steps that you need to follow. The first one is you need to identify u, which is the inside function. Right? So when you look at the problem, you need to identify, oh, what is my inside function? And then from there, you take the derivative on both sides of the inside function and say that, okay, find du in terms of x and dx. We're going to go through that later. Third step is that after the substitution here, after the identification of u, you say that, okay, I'm going to substitute what I get from part 1 and 2 into the original integral, and I'm going to get the new integral in u and du. After that, go into step 4. I'm going to find an antiderivative, which you know how to do, and move on to the last step. After taking the antiderivative, you need to resubstitute what you get from the beginning and put that in terms of x, because you start with something in x, you need to end up with something in x. So let's tackle this problem and try to follow these 5 steps. The first thing, right, step 1, try to identify u. So usually you can see here, if anything inside the parentheses, usually, not always, usually anything inside the parentheses is considered the inside function. Another way to look at this problem is that you see the expression 5 plus x to the 8. If you take the derivative of this expressions, you're gonna get something related to x to the 7. Let's do that. So I'm gonna let u equal to the inside function 5 plus x to the power 8. Now that is step 1. Step 2, find du in terms of x and dx, and that is take the derivative for both sides of this equation. You get du dx equal to, so the derivative of 5 is just 0 because 5 is the constant. And then the derivative of x to the power 8 is a times x to the 7. As I mentioned in class, you need to multiply both sides for the x. Therefore, you get du equal to 8 times x to the 7 dx. You see here, you have something related to the inside function. You let it equal to u, take the derivative, then you have du equal to 8 times x to the 7 dx. You go back and look at the original integral. You say that, okay, the inside function is right here. I have that equal to u, that's good. But you left with x to the 7 dx. And you go back here for the substitution part. You say, okay, I have x to the 7 dx, but I still have the 8 here. Can I get rid of it somehow? So the way to do this is just divide both sides for 8. And you end up with 1 over 8 du equal to x to the 7 dx. This is good, because now not only you have u equal to the inside function, x to the 7 dx now equal to something related to du. So this is step 2. Move on to step 3. You're going to substitute the inside function u and du here into the original integral, and you get the new integral in terms of u and du. That is, this is the integral of u to the power 19. And then x to the 7 dx is actually equal to 1 over 8 du. So you write 1 over a du. And then from here is very typical integral that you can find the antiderivative. So 1 over 8 is the constant. You can bring the constant out of the integral operation. That is 1 over 8 times the integral of u to the 19 du. And this, you can apply power rule at this point. U to the 19. Power rule of that is u to the 19 plus 1 divided by 19 plus 1. And don't forget to plus c at the end. So either you can leave it here or you can simplify a little bit to make it look nice. So 19 plus 1 is 20. So you have 1 over 8 times u to the 20 divided by 20 plus the constant c. So this is step 4. This is the step of finding the antiderivative. Now move on to the last step, step 5. Here, everything, the expression you have here in terms of u, but you start with something in terms of x. You need to resubstitute that into the final answer. So that is 1 over 8 multiplied with u is equal to 5 plus x to the 8. That is 5x to the 8 to the power 20 divided by 20 plus the constant c. You can just leave it like this, and that is your answer. A lot of you have asked me before that, oh, should I simplify the denominator? It's up to you. If this problem is in the free response, is one of the free response questions, you can just leave it like this. We okay with this. But if this is the multiple choice, please follow some of the choice that they give you, that you might need to simplify the denominator. If not, that's okay. So for the next problem is another type of integration by substitution. You look at this problem and you see that, okay, how can I identify u here? So one more time, you look at the terms that when you take the derivative is related to something else in the integral. So I look at this problem, the integrand, I see that, okay, there are x cubed. And if I take the derivative of x cubed, I have something related to x squared. So that x cubed is the inside function. Okay? And some of you, if you don't see this very clearly, oh, how is x cubed is the inside function, it helps if you think the function, exponential function, as instead of e to the power something. Usually in computer science or in the calculator, some of your calculator is actually express e as exp, exponential function, and they have some parentheses like this. So e to the x cubed is actually, you can rewrite that in terms of exp of x cubed. So x cubed here in this case clearly an inside function. So let u is equal to x cubed, the inside function. So that is the first step that you have. So I'm going to mark here, this is the first step. Now move on to the second step. You need to take the derivative on both sides of this equation, u equal to x cubed. And you have du dx. The derivative of x cubed is 3x squared. Now you write this in terms of du equal to 3x squared dx. That is, for this equation, you multiply both sides for dx, and you have du equal to 3x squared dx. So this is the second step. But once again, after taking the derivative, you say, okay, I have du equal to 3x squared dx. Now I look back to the original integral. I don't see 3x squared dx. I just see x squared and dx. So that means I have to get rid of the 3 here. To do that, just divide both sides for 3. And you get 1/3 of du equal to x squared dx. Now move on to the next step. You see that I have u equal to x cubed and 1/3 du equal to x squared dx. I'm going to substitute that to the original integral and get the new integral in terms of u and du. So I'm going to write over here. So this is equal to the integral of e to the u. So you have e to x cubed, which is e to the u. You left with x squared dx. And what is x squared dx equal to? It's equal to 1/3 du. So you write 1/3 du. So this is the third step. You get the new integral in terms of u and du. And the next step, you need to find the antiderivative. Once again, 1/3 is the constant. You can move the constant out of the integral operation. You have 1/3 times the integral of e to the u du. And you know that the antiderivative e to the u is just e to the u itself. So that is 1/3 times e to the u plus the constancy. Don't forget the plus constancy at the end. So this is step 4. You have the antiderivative. But now because you start with something in terms of x, you need to end up with something in terms of x. Don't forget that. So move on to the last step. You need to resubstitute u equal to x cubed into the expression. So you have 1/3 times e to the x cubed plus the constancy, and that is the last step. Now move on to the next problem. Problem 3. You have the integral of x cubed times sine of x to the 4th plus 1. So this problem is very easy to identify the inside function because you have x to the 4th plus 1 is the inside of sine. So you're going to let x4 plus 1 is the inside function. So let u equal x to the 4th plus 1. Then you take the derivative for both sides of this equation. You have du dx is equal to 4 times x cubed. And as I mentioned before, you multiply dx across on both sides of this equation, and you have du equal to 4x cubed dx. So you have the inside function is x to the 4th plus 1, right? That is u. And you left with x cubed dx. But in here, you have 4 times x cubed dx. We gotta get rid of the 4. That means divide both sides for 4. You have 1/4 du equal to x cubed dx. So this part we have done. Step 1, try to identify the inside function. Step 2, write du in terms of x and dx. So this is step 2. And step 3 is that you're going to substitute what you know in step 1 and 2 back to the original integral to get a new integral in terms of du and u. So that is, so you have sine of x to the 4th plus 1, but x to the 4th plus 1 is u. So this is the integral of sine of u. You're left with x cubed dx. And x cubed dx is equal to 1/4 du. So that is 1/4 du, like this. At this point, it's very simple to get the antiderivative. This is something you have learned before. This is something you are tested in test 1. So once again, 1/4 is the constant. You can bring constant out of the integral operation. You left with the integral of sine of u du. And what is the antiderivative of sine of u? You need to be careful here, right? Because the antiderivative of sine of u is actually equal to minus cosine of u. So this is 1/4 times minus cosine of u plus the constancy. You can rewrite this as negative 1/4 times cosine of u plus the constancy. This is the 4th step. And the last step is you resubstitute what you know about u in terms of x. And you have minus 1/4 times cosine of x to the 4th plus 1 plus the constancy. So this is the final answer. So for this problem, the integral of 3 to the power 2x plus 1 dx, it's a little bit hard to find the inside function, but for this, when you look at the function 2x plus 1 and you say, okay, if I take the derivative of 2x plus 1, I have something related to the constant only, which help, right? So because of that, I'm going to choose 2x plus 1 as the inside function, okay? So let u equal to 2x plus 1. And if I take derivative on both sides of this equation, I have du dx equal to 2, because the derivative of 2x is just 2, and the derivative of 1 is the 0, because 1 is the constant. Now you can multiply across dx and you have du equal to 2 times dx. But once again, when you look back to the original integral, you say, oh, I don't have 2 times dx, I just have dx. How can I get rid of the 2? Very simple, you just divide both sides for 2, and you have 1/2 du equal to dx. So this is the first step, this is the second step. Now, using the information in the first two steps, substitute back in to get the new integral in terms of u and du. So that is 3 to the power u multiply with 1/2 du. 1/2 is the constant. You can bring that out of the integral operation, and that is 1/2 times the integral of 3 to the u du. So the antiderivative of 3 to the u is supposed to be 1 over ln of 3 times 3 to the u plus the constant c. This is the third step. And the last step is that you substitute what you know in terms of u in terms of x back to the final answer. You have 1/2 times 1 over ln of 3 and multiply with 3 to the power 2x plus 1 plus the constant c. For problem 5, this is the new type of integration by substitution. So anytime you see this kind of problem, try to identify the inside function is a little bit hard because it's actually in the denominator of the function. So in this case, 2x squared minus 1 is the inside function. First of all, because if you look at this, if you take the derivative of 2x squared minus 1, you have something related to x only. So that's why I have that as the inside function. Let u equal to the inside function 2x squared minus 1. The derivative of this is du dx equal to 4 times x. And then because, okay, the derivative of 2x squared is 4x, and the derivative of minus 1 is just 0 because minus 1 is the constant. Now multiply dx across, you have du equal to 4x dx. Now go back to the original integral. It's a little bit hard for this problem because you're left with 5x dx, right? But 5 is actually the constant. Do you remember that I say, okay, I have a constant here, I can bring that out of the integral operation. And if I rewrite this original integral, I have 5 times the integral of x over 2x squared minus 1 dx. This is good because I don't have 5x dx anymore, I just have x dx. And because of that, I go back to the substitution part here and I say, okay, I have something related to x dx. I just need to get rid of number 4. Right, so this, you divide it both sides for 4. It becomes 1 over 4 du equal to x dx. This is the first step. This is the second step. And from the first step and the second step, you use this information, substitute back to the integral, and you have 5 times. So x dx is what? X dx is equal to 1 over 4 du. So I write 1 over 4 du. And you have something divided by 2x squared minus 1. Right? That is 1 over 2x squared minus 1. But 2x squared minus 1 is the inside function, which equal to u. So you have 1 over u. Just to be clear, this is all multiplication. So 1 over u multiplied with 1 over 4. Once again, 1 over 4 is the constant. Bring that out of the integral operation. You have 5 times 1 over 4. You're left with the integral of 1 over u du. Be careful here for the antiderivative of 1 over u, because you cannot use the power function, because 1 over u has a special formula to that. So the antiderivative of 1 over u is ln of absolute value of u. Don't forget the absolute value, okay, plus the constancy. Now at the end, this is step 3, this is step 4, and now at the end you need to resubstitute u back. So because u equal to 2x squared minus 1, I have 5 over 4 times ln of absolute value of 2x squared minus 1 plus the constancy. So for number 6, it's very similar steps as we did in problem number 5. So this is the fraction, and usually for this type of integral, the denominator is the inside function. Another way to look at this one more time here is when you look at 4 minus x to the 4th and you take the derivative of that, you have something related to x cubed. So let u equal to the inside function 4 minus x to the 4th. And when you take the derivative both sides of this equation, you have du dx equal to minus 4x cubed. You take the derivative on both sides of this equation, you have du over dx equal to minus 4x cubed. And you can multiply dx across and you have du equal to minus 4x cubed dx. So this is the first step. This is the second step. But from here, you look at the original integral and you see that, okay, I have x cubed dx left. But here for du, I have minus 4x cubed dx. I want to get rid of negative 4. So that is, you need to divide both sides for negative 4. You end up with negative 4, 1 over 4 du equal to x cubed dx. Now you substitute u and something related to x dx back to the original integral. It's a little bit hard to see, but it helped if you can rewrite the fraction in terms of 1 over 4 minus x to the 4th, and then you multiply with x cubed dx. So this step helps you to see that, okay, I have something related to the inside function only, and then I have something related to du itself. Okay, so therefore this is the integral from 1 to u, because 4 minus x to the 4th is equal to u. And you left with x cubed dx. That is negative 1 over 4th du. So I write negative 1 over 4th du. Anytime you see multiplication like this and you have a constant negative, in this case negative 1 over 4th, you can take the constant out of the integral operation. You have negative 1 over 4 times the integral of 1 over u du. So this is the third step, that you need to find a new integral in terms of u and du. Step 4, you need to find the antiderivative. As I mentioned in problem 5, the antiderivative of 1 over u, you have a special formula to that. That is negative 1 over 4 times ln of absolute value of u. Don't forget to plus c at the end. This is the fourth step of finding an antiderivative. For the last step, you need to substitute u equal to 4 minus x to the fourth back to the answer. That is minus 1 over 4 times ln of 4 minus x to the fourth plus the constant c. And this is the last step. For problem 7, you have a fraction function cosine of x over sine of x. And as I mentioned before, for this kind of fractional function, the denominator is usually inside function. So let's choose sine x as an inside function. Also, when you look at sine of x, what is the derivative of sine of x? It's actually cosine of x. So that's why we choose sine of x as the inside function. So I let u equal to sine of x. If you take the derivative for both sides of this, I have du dx equal to positive cosine of x. So you need to be careful. We're talking about the derivative, not antiderivative. Okay? So from here, you multiply dx across and you have du equal to cosine of x dx. And you go back, you have step 1, identify the inside function. Step 2, you write du in terms of x and dx. And you go back and look at the original function. You say that, okay, I have the inside function to be u. And I left with cosine dx, which is du. So my job is done, right? So you just substitute what you know in step 1 and 2 back to the original integral. And you get the integral of 1 over u, and you left with cosine x dx, which is equal to du. This is step 3. And step 4, you find the antiderivative of 1 over u. So one more time, you need to be careful with the integral of 1 over u, because it is equal to the ln of absolute value of u, then plus the constant c at the end. This is the fourth step. And the last step is that you resubstitute u equal to sine of x back to the answer you got here. That is ln of absolute value of sine of x plus the constant c. This is the last step, step 5.